Okay, welcome back. So the next thing to do with our hypothesis testing is to do a two-tailed test. So a two-tailed just means that it's one of those situations where we don't know whether to expect this to be higher or lower. We just are assessing whether something is equal, and it could be higher or lower, and we're going to look at the results, and that'll direct us in one side or the other. But the significance of it being a two-tailed test is that we're taking our significance level and we're splitting it into two pieces. So it's very similar to what we did before, but we're going to do two-tail and evaluate our null hypothesis that way. So first of all, I've got a claim here based on this study. Average age of a community college student, 20 years old. And so we want to do our null hypothesis or alternative hypothesis. We'll let you do that. Remember that you did some practice back in here, and you had an example that was different from, and so that should help you get this the hypothesis set up. Now, I tried to build this off of a real set of data, and so we're going to do a randomly selected sample, which means your sample is going to be different than my sample. So to sample, and we did this last week with our sampling trials. I've got data back here. You don't need to look at it, but I'll just show it to you briefly. No fill, there it is. Back to black. And so what I want you to do is I want you to shuffle the data, smallest to largest, and that will then give us new results here. There is a little line in A that says grab down to here. So I'm going to start here and go up. I'm going to copy, I'm going to paste, and then I'm going to uncover my sample. And this is my data. So if I did this again, that would not be my data. I'm just going to go ahead and show 40, 28, 22. All right, fine. And I will delete that. And I'm going to do this again. So if I do smallest to largest, go to here. It was like 40, 22, 28 or something. Paste, take off this. Totally different. Oh, I got some old people in this sample. Okay, so well, we're trying to just kind of reproduce the process of doing an actual hypothesis test. So we did a sample. After stating our null and alternate hypothesis, and now I'm going to do my mean. My mean is going to be different than your mean. I got 50 people here in my sample. So I'm splitting my significance level into two equal parts. So 2.5%. I've got my standard deviation population. I'm using 28 as my value that I'm assuming is the right number. I'm going to go back here and I'm going to look at this equation. In fact, I might just copy and paste this over here because I don't have a good memory. So now I'm going to do my calculation, which is that the z-score equals, remember to get all your parentheses in here. My value is 29.2. I think it's 28. And I'm going to take my standard deviation, which is 5.6, and divide it by the square root of 50, which is the size of my sample. And I've got 1.515. This is my z-score. This is my z-test. And now I have to turn this into a percentage. Your numbers are not going to be the same as my numbers. You might get a different result. Now we're on the high side of the 28, so we're above the mean, positive z-score. And I'm going to turn this into, what's the chance I get that number or higher? 1 minus norm.f.dist. Z-score, comma true. And we're looking at a 6% chance. Is this strange enough to reject the null hypothesis? The answer is, pause, try to answer the question yourself, see if you got the right answer. The answer is no. We fail to reject the null hypothesis. Your answer could be different based on this sample. So, although the sample was higher, the average age was 29.2, and that's higher than what this study claims. It's not high enough to be strange enough to be a result that causes us to reject the null hypothesis. And that's setting our bar at 2.5%. Even if we had done a single tail test at 5%, it wouldn't have been a good enough result. So we failed to reject the null hypothesis based on the sample, which means, I don't know. I mean, it's not like our research is a failure. This is how science works. Sometimes, we can draw conclusions. Sometimes we're not ready to draw conclusions. We got to go back and do more research. So that's the end of our videos. The 2 practice problems here require you to go through all of those steps. Again, the OpenStax statistics book is a place that you can go for support. Looks like the top of this is kind of cut off. Yeah. So if you need to expand this a little bit, you can expand it. You're going to work through the process and you're going to come to some kind of conclusion. The conclusion is either going to be, I reject the null hypothesis or I fail to reject the null hypothesis. And that is the end of hypothesis testing. All right. Let me know if you have questions for me about that. Don't forget, I'll just put in a few reminders here about everything else that's going on, coming to the end of the course. Really, really strongly recommend you look at the final project, especially this is a little bit of a lighter workbook. So take some time, look ahead, submit some draft work to me, get some feedback on the tasks. And we're going to talk in week 9 about getting you started. If you haven't done anything by that point, we will get started at week 9. Okay. Be good, work hard, be in touch.